Good evening, everyone, and welcome. My name is Steve Dragich, and I have the honor of serving as the president of the JDRF Illinois Board of Directors. I am proud and excited to welcome you to tonight's meeting. I think I can speak for many of us when I say that I am very much looking forward to in-person events again soon. But tonight, we're ready for an informative annual meeting once again via Zoom. Tonight, you will hear about chapter successes and what made the year a memorable one. Aside, of course, from virtual events, pandemics, and unprecedented times. But first, I want to say thank you. By being here tonight and supporting JDRF, you are making a real difference in the lives of those living with T1D. First, let's talk about why we are here today. Science and research have defined and guided JDRF for over 50 years. JDRF was built on this notion of accelerating scientific breakthroughs to make the lives of those living with T1D as manageable as possible. And it's exciting to see the effort and dedication that continues to drive this mission forward, especially in this challenging fiscal year. Now to share some exciting financial information. We knew this year would be tough and trying for JDRF financially. But even during this year, we have amazing results to share. FY21 actual has far surpassed our budgeted expectations. That is what we are here for, to raise money and fund a cure. In addition to the over 18,000 gifts we received this year, we had 2 gifts at the $1 million level and have just received our 3rd transformational gift of this fiscal year. While you are not seeing it in our annual total for fiscal year 21, we have a confirmed gift from Daryl and David Nelms for $2.5 million. Amazing. For those of you who are new to the organization, the Nelms family became involved with JDRF when their young son was diagnosed with type 1 diabetes. They first became involved with our walk program, then gala, and then David stepped into a board member role, first at the chapter level and then on our international board. As CEO of Discover, David also led initiatives in that organization to support the important work of the JDRF. We want to thank both him and his wife, Daryl, for this incredibly generous gift. I now want to take a moment to thank those board members who are retiring at the end of fiscal year 21. Thank you, each of every one of you, for taking an important leadership role in our chapter. And remember, we know where to find you for additional help in the future. Here is a list of our returning board members for this next fiscal year. Their work and dedication to the mission is unwavering, and I look forward to working with all of them this year. This next slide introduces our 14 new board members. As you can see, we have a fantastic group joining us. What remains constant amongst them all is their energy and passion for JDRF and finding a cure. Welcome. Finally, I would like to introduce and welcome the incoming Executive Council for their commitment to serve this coming year. Now let's step back from our chapter and look at what's happening with JDRF both nationally and internationally. Recently, we heard messaging that underlined just how much T1D affects people everywhere around the globe. First up is a video that talks about the JDRF Global Project. After that, you'll hear from JDRF CEO, Dr. Aaron Kowalski, that highlights the research funded in 2020. Let's watch those videos together.
I'm Tom Robinson. I'm co-lead with Mike of the Global Project, and it's exciting to have this opportunity to tell you all a little bit about it. Let me begin by telling you some lies. One, these days, type 1 is relatively safe. 2, type 1 is a rich country problem. 3, type 1 is the little cousin of normal diabetes. Now, we all know these to be lies. Now we have the data to show it. Let me set aside the name diabetes for a moment. What if we could tell the world there was an autoimmune condition? And James, if you advance one slide, an autoimmune condition that back in the 90s, yes, had mostly been confined to a small number of people in a small number of countries. But in the years since, this mysterious autoimmune condition has grown quickly. And of course, we have fought back. We helped develop analog insulins and pens, which created rapid-acting alternatives and easier and more accurate delivery methods. Pumps made their debut, CGMs made their debut, they both became more widely used, and now artificial pancreases offer so much promise. Truly, we have achieved incredible things together. But advance one more slide. For all these great strides, the picture in 2020 is of a world more burdened by type 1 than ever before. Look at how those circles have grown. Look at that line extending across the bottom of the chart. And yet even this picture is incomplete because it only shows us those who are living with type 1. And yet, as we all know far too well, too many are taken from us before their time. And if we begin to count this population of ghosts who should be with us today, together with the living, then the true picture of type 1 looks like this. Next slide, James. Oh, back one. There we go. What you see is a fast-growing, large autoimmune condition that is affecting nations from DC to Delhi, and which is moving with cruel speed against the global south. This is a condition that in the next decade will rival HIV as the largest, most dangerous chronic condition on the planet. That's how the picture has changed. And for us at JDRF, this is a picture of need, but it is also a picture of opportunity. It is a picture of need because people are living tough and they're dying young, and they're doing it without access to the tools that they need to live a rich, full life with their diabetes. But this is also a picture of opportunity because today we at JDRF are already achieving great things while tapping into less than 20% of the population and economic strength of people living with type 1. Imagine what we could all do to accelerate life-changing therapies if we had 5 times the resources and 5 times the bright and curious minds dedicated to this fight.
Hi, everybody. It's Aaron here. It's so wonderful to be with all of you today because you are our foundation. Just like our 2 founding moms, they leaned in and started this organization to drive for a cure for their boys. T1D hasn't stopped during this pandemic, and we will not stop. Since our founding 50 years ago, JDRF has played a critical role in the advancements of the novel treatments that are helping people with T1D live healthier and easier lives. I'm so incredibly proud of the role that our team played in driving artificial pancreas systems to the market. Here we are wearing hybrid closed loops, more time in range, less hypoglycemia, less high blood sugar, less variability, more sleep, lifting some of the burden off our shoulders. Our regulatory team worked with FDA. We now see these systems approved down to kids as young as 2 years old. And now we're pushing even further with Tidepool to develop Tidepool Loop, taking the DIY loop and bringing it through the FDA process into app stores. What the benefit of this would be allowing people with T1D to pick the pump that works for them, the sensor that works for them, the algorithm that works for them, plug and play. I mean, this would be amazing. And of course, treatments that's not the end game. The end game is curing T1D. T1D cures and preventing it from happening in our next generation. And I really believe that we're in a renaissance time in diabetes research, that we're at a turning point that we'll see what we call disease-modifying therapies becoming real. One of the big steps that we've seen over the last year is teplizumab. And in clinical trials, the company Provention that owns this drug and was part of our T1D fund has shown that teplizumab can delay the onset of T1D for nearly 3 years in people who are certain to develop type 1. It's at FDA, and if approved, it would be the first disease-modifying therapy for type 1 diabetes, one of only 2 autoimmune diseases that doesn't have something that changes the course of the disease. So this advancement, teplizumab, is incredible. But it's part of a portfolio. JDRF, we want multiple shots on goal. And that is critical because it's not just a cure. There are going to be multiple approaches that will drive us ultimately to walk away from type 1. Now, another just wonderful project that I'm incredibly excited about is T1 Detect. Of course, if we want to prevent type 1 diabetes, we need to know who's at risk. And this initiative allows people an early way to test through a simple blood test if you have the markers that confer high risk for developing type 1, even before symptoms develop. These examples show that T1D research is advancing at an unprecedented rate right now. But of course, we're not satisfied. We want to move even faster. And JDRF is constantly looking at how do we accelerate life-changing breakthroughs faster and faster, looking for innovative scientists with the best research institutions here in the United States and around the world. In 2016, we created the JDRF T1D Fund, a venture philanthropy fund that invests in small companies with innovative potential solutions to better treat, prevent, or cure T1D. And this is driving more private capital towards our mission, leveraging dollars to drive the JDRF mission and ultimately translating the scientific breakthroughs that we're seeing in the lab in academic institutions into actual therapies and technologies that will help our loved ones and those of us living with T1D. I think the fund is just absolutely amazing. It's game-changing, and it shows that ultimately to move things into the hands of people with type 1 diabetes takes us looking at the entire pipeline from R&D to translation to ultimately delivery. Now, another critical component of that, and you want to talk about super leverage, is our work with the federal government and our special diabetes program. Through just amazing advocacy, tireless work, many, many meetings, our team in DC and volunteers around the country, we saw a bipartisan 3-year renewal of the SDP for $150 million a year. Many of these advancements, of course, JDRF has played a critical role over our 50 years. NIH plays an equally critical role. These advancements go hand in hand. Our scientists are on a weekly basis communicating with the NIH scientists. And this money helps drive our mission forward. So yes, we've seen incredible progress, but we're not satisfied. We need to continue to drive our mission forward, to accelerate those life-changing breakthroughs for T1D. How do we do that? We need to engage more people. We need to broaden our outreach. We need to be a more diverse and more global organization. We need to double down on our advocacy efforts because ultimately research and development is only meaningful if people with diabetes are achieving better. We need to ensure that as new therapies, new treatments, new devices reach the market, they're affordable and accessible. Of course, this all happens through our incredible volunteers. The staff volunteer partnership at JDRF is foundational. And it's because of folks like you that we will see the realization of our shared goal, a world without type 1 diabetes.
Thank you, Aaron. It's just amazing to me to think that you started as a CEO just a year ago, only months before COVID. So all of us want to thank you. And when you look at the global impact of this disease, it does give you pause. But as Aaron shared, we have a lot of reasons to be hopeful. And as you've already heard, it has been an extraordinary year. I found it difficult as I looked at the annual meeting is how to share exciting news when we know that the world, the country, community, everyone has suffered because of COVID. And for JDRF, it was one of the hardest years in our history. But I'm proud to say that as a chapter, we persevered and we have found new ways to make an impact. So what I'd like to do now is share a little video that tells the Illinois chapter story.
We started off our fiscal year 2020 on such a high. We'd come off one of our record-setting years. We had an amazing gala, and then we had COVID. And then that just changed everything. In any other time, this disease is really difficult. With COVID, it just went up a notch. We stepped up quickly and started addressing the medical concerns, making sure that we had the answers and the resources to put people at ease. Behind the scenes, the team is all looking at how do we pivot? How do we engage people in a world where we couldn't engage people? What is a walk when you don't walk? And what is a ride program when you can't ride? You know, what is a gala when you can't gather together?
This year's new virtual event will be one you don't want to miss.
Good evening, everyone, and welcome. Even though we had to do this virtually this year, the mission remains the same.
We were ready to plan and take it on. And I think those challenges make for a strong team. It was rewarding, but to say that it wasn't hard, this was an emotional roller coaster that got us to a very good end. JDRF should take a lot of pride in what we did. We're a mighty staff, but boy, when you put it with a strong board and strong volunteers and the national team that backs you up, it is a winning formula.
$8.5 million.
Our hope is that we're going to see the results of all that we did last year in staying connected and communicating and providing resources. I want people to pick up the phone and call us because it is a scary thing and they shouldn't have to feel like they have to do it on their own. Everything that we do is for the community. We just take pride in the fact that we do it well. We've gotten through this, we're stronger, and we can do better. And I think that's sort of the challenge for next year.
So the reason you saw that video when I'm sitting here right in front of you is that, to be honest with you, I wasn't quite sure if I was going to be able to get through that story. It has been a tough year, and while I don't want to dwell on it, we have to talk about COVID and the impact that it had on the community, and particularly the stress that it created for our T1D community. I'm really proud of our coronavirus page, which, as you can see on the screen, it netted over 250,000 hits of people looking at it. And we launched it last year, not just for our families and our individuals, but also for healthcare providers and diabetes experts who are looking for resources and answers. And we worked diligently to raise awareness. And then when it came to the vaccine, JDRF stood up again, helping the community, pushing hard that we would get approval. As a chapter and as an organization, I think we did an amazing job stepping up, and I'm proud of the fact that we made it priority number one for last year. But we also went through a reorganization last year, which, while challenging and difficult, helped us stay strong. Our chapter, even though we reduced our staff by nearly 50%, stayed focused. And as Steve said, we did a good job of raising a lot of dollars for research. One question that I always get is, well, what's the impact? What's the focus on the cures? And I think this chart here explains a little bit about how many dollars we put to our focus, our mission, which is cures. The first chart shows you how much we deployed for research grants, and the second one shows the impact of the newly organized T1D fund, which is investing in novel companies with the promise of T1D therapies. I do say the future does look bright, and when you can say that after 4 years we've put $644 million towards a cure, then I know that the work we are doing is meaningful. And we don't just work in that direction, we also pivoted to a new idea, which was the T1 Detect program. It's a new screening, education, and awareness program that's part of our cure strategy. It was approved last December, and basically what it means is that anyone can get tested for type 1. It will allow you to know in advance, to plan, to prepare for the future, to prevent a hospital emergency, and most importantly, the risk of DKA. If you knew in advance, you can manage for it. Now, we've had programs before that were for families, but this is for the entire community to take the test, and I hope you will learn more about this, as I think this is really an innovative way to think about our future. And as Aaron said, we do a lot. Every year you hear about advocacy, and that's because that special diabetes program is so critical. The amount of dollars that we fund, that they fund, is something we couldn't touch. $150 million a year. That money is going to researchers. That money is going to new opportunities. And so we put a lot of focus on advocacy. We know that the research has to lead for us to have better outcomes. And of course, it isn't just about the research, because I think we're always concerned about the individual. And so that's why our advocacy team also works hard on coverage to control. That means that we are adamant about taking care of those with pre-existing conditions, making sure they have access to comprehensive health care, taking care of the youth and the parents so that they can keep their kids on insurance until the age of 26, prohibiting limitations on healthcare insurance for individuals, and also making sure that there's coverage in Medicare. This disease is all ages and all stages, and JDRF addresses that. And people with T1D need access to insulin. And so the work that we do with our insulin manufacturers, health insurance providers, pharmacy benefit managers, and employers are all in an effort to make insulin more affordable. So with that, I have to say that the future is bright, the work we are doing is strong, and the progress we make, you have a chance to hear from one of our acclaimed researchers who will share the hope of the future. Heather, would you like to introduce him?
Yes, I would love to. Thank you, Mimi. JDRF's priority has always been to fund research to help treat, prevent, and ultimately cure type 1 diabetes. And thanks to years of investment by JDRF, we have incredibly promising windows for curing T1D on the horizon, including cell therapies and disease-modifying therapies. Tonight, we want to highlight a specific research area that JDRF is funding for those living with T1D, so you can see an example of exactly what your donations are supporting. I would like to welcome Dr. John Odorico. Dr. Odorico is Director of the Pancreas and Islet Cell Transplantation Programs and Professor in the Department of Surgery, Division of Organ Transplantation at the University of Wisconsin-Madison School of Medicine and Public Health. The school's pancreas transplant program consistently ranks among the highest volume programs in the world and has developed many field-leading innovations. In addition to research, Dr. Odorico is certified by the American Board of Surgery and specializes in pancreatic, islet cell, and multi-organ transplants. He received his chemistry bachelor's from Duke University and his MD from New York University. I'm very excited to welcome Dr. John Odorico. Dr. Odorico.
Thanks, Heather. And thanks, Mimi, and thanks, Stephen, as well. And thanks to the whole JDRF Illinois chapter for inviting me to speak with you tonight. I'm really honored to be here. Can you guys see me and hear me okay?
Looking good.
All right. I just want to make sure the volume was okay. So again, thanks for inviting me. I'm really honored to be here. And what I thought I'd do is take a few minutes to share with you what we're doing in the lab that's funded by JDRF. And this project has, I think, transformative potential. It's still in the experimental phases where it's not a clinical study, but we're very, very excited by it. It combines some field-leading technologies together in a synergistic way that really is able to answer some key questions and provide some key modifications to cells that might allow them to escape rejection and autoimmunity. So let me tell you a little bit about what this project is about. Let me give you more or less the title of the project. And the title of the project is Genetic Engineering to Immune Cloak Stem Cell Derived Islets for Treatment of Diabetes. So let me unpack that a little bit. What I mean by genetic engineering is using the modern technology of genome editing to modify cells. This technology basically received the Nobel Prize this year for medicine. It's based on some experimental work many years ago on the immune systems of bacteria and how they avoid infection by what's called phages, or small viral particles. And this is CRISPR-Cas9, TALENs, and other ways to modify. And what it does is provide like genetic scissors to make modifications in our DNA, in the cell's DNA, in a footprint-free way that does not potentially create mutations or other modifications or changes in the cell behavior. And this is a modern technique that's only become available over the last several years, but has become relatively cookie cutter and recipe driven in a variety of labs, but it still takes a fair amount of expertise. So I'll tell you who we collaborated with to make some cells to do this a couple of years ago. So immune cloaking, what are we going to do with this genetic engineering approach? Well, we can do a lot of things. Among them, we're interested in finding ways to prevent rejection, that's immune-mediated damage of transplanted cells, and to protect them from the immune system. So like you guys all remember or have seen Harry Potter probably, and know the invisibility cloak. And so this is the concept. If we cloak the cells with proteins by eliminating some proteins on the cell surface or overexpress some proteins that have immunomodulatory capacity, meaning downregulating the immune system, blocking the immune system, we can potentially cloak the cells and make them avoid immune rejection or autoimmunity. So that can prolong the life of the cells after transplant. Now we're working in the stem cell field and have worked on human pluripotent stem cells for many years. I think I was among the very first scientists to think, can we treat diabetes or cure diabetes with stem cell derived islets? That was an initial concept back in the early 2000s. And now it's come to that some of these cells are entering clinical trials, and I think there's a lot of preclinical research to be done yet, but still there's a lot of promise to this field. You've all heard of Doug Melton at Harvard, a good friend who have shared the podium with at various conferences that we've organized together. But it's not just me and it's not just him. It's quite a few researchers across the world working on this concept of, can we make insulin-producing beta cells and other endocrine cell types from human pluripotent stem cells. So, and it's not a new concept. It's been around for some 20 years now, but it's finally coming to clinical fruition with some early clinical trials. So those three things: genome modifications to immune cloak and prevent rejection and autoimmunity in stem cell derived islets. And that's the essence of this project. It's a phase project over 3 years. It's just been funded in January with support from a person actually, in fact, who donated a fair amount of money, state money, to JDRF. She was a prior kidney and pancreas transplant recipient at our center, and grateful to the generosity of her family, and of course, all of you who support the JDRF mission and other research projects. So what's the rationale behind this project of generating a set of cells that can produce insulin that are unlimited amount that we could transplant, that would be prevented from recurrent autoimmunity or rejection, and that could survive in a human? So the clinical problems is that you know, as you well saw from the videos early, this is basically a pandemic that's been ongoing for more than just a year. Diabetes, either type 1 or type 2, but in particular type 1 is affecting global populations, not just developed countries, but emerging economies as well. And it's really a disease that's growing, and insulin and the new pumps and CGMs and artificial pancreas, all technology that is more available now to a greater percentage of the population, is great. But despite that, there's still only a minority of patients that achieve their glycemic targets, their blood sugar targets, and hemoglobin A1C targets. There's some data from the ADA and from JDRF suggesting that even with modern technology, although more patients are benefiting from that technology and more patients are achieving their glycemic targets, it's still only about 33% of patients can achieve their glycemic targets, even with the best technology. And of course, insurance and other things, all of which JDRF is advocating for, as you heard from Mimi, are very important aspects of the JDRF mission, are enabling better access to these therapies, but still they're not perfect. We know that even patients who are on insulin for many years still suffer from kidney failure, eye disease, nerve disease. It might be blunted, it might be delayed, but it's still prevalent. We know from transplanting insulin-producing cells that patients can completely eliminate insulin use, completely eliminate the need for technology, completely eliminate hypo events, normalize their hemoglobin A1C, and potentially prevent, and likely prevent, as long as that normal blood sugar control is achieved, completely prevent end organ damage from eye disease, nerve disease, kidney disease, etc. So we know there are still problems and still things to overcome. The problems being with transplant therapy, of course, pancreas transplant in particular is very invasive. There's a shortage of donors, with 64,000 patients, newly diagnosed diabetics every year, and millions in the United States alone. We cannot have enough donor organs to transplant every patient. And so most patients don't get access to transplantation therapies. Only about 1,000 pancreas transplants are done in the United States every year because of the shortage of organs. So the shortage of organs, but also the possibility and specter of rejection, the need for chronic immunosuppression, and the problems that chronic immunosuppression causes. While transplant therapies are better and better every year, still there are life-threatening and life-shortening events related to rejection and immunosuppression-related complications, not to mention surgical complications. Of course, pancreas transplant is very invasive, as I mentioned. It's also very expensive. The drugs are very expensive, and the treatment, the surgery is very expensive. Now that's the problem. Now the solution that I described of stem cell derived therapies without immunosuppression and with potential immune cloaking by just simply modifying the cells genetically beforehand are potentially transformative. So stem cells can provide an unlimited source of cells, and so we could treat millions and millions of patients. The same cells that Jamie Thompson derived at the University of Wisconsin, human embryonic stem cells and human-induced pluripotent stem cells, are ones we actively use in my laboratory today. It's the same initial batch of cells. So that's amazing. It's gone through many, many fold growth and proliferation and expansion over the years. So not only an unlimited supply of cells, but the immune cloaking, as I mentioned, might allow the elimination, complete elimination or partial elimination of immunosuppression and prevention of rejection and recurrent autoimmunity. So that's really an advantage of these cells because they can be manipulated outside the body beforehand stably without risk of potential mutations. Of course, the cells would have to be checked for that after the manipulation, and then transformed and put back into the patient. This therapy would be less invasive than a pancreas transplant. It would be a simple infusion of cells. Very much akin to cadaver islet transplants. The exact same procedure could be applied. It could be very effective. In fact, that's what we're proposing and companies are proposing in part in some cases. So this cadaver islet transplants, while it's donor limiting, cell limiting, requires immunosuppression, it shows us as proof of concept that you can achieve immediate and in some cases long-term insulin independence, freedom from insulin in patients getting cadaver islet transplants in the liver. It's not successful in all patients for sure, but this approach as a first approach for a stem cell derived islet I think is a very rational one. We anticipate stem cell derived islet therapies of any sort to be ultimately cheaper than pancreas and a cadaver islet transplant. Those therapies, those existing therapies now, based on cadaver donors or deceased donors, cost about $300,000 for the therapy and then additional costs for the years worth of immunosuppression. But I think many people estimate that enough stem cell derived islets for a particular patient can be generated with about $20,000 to $25,000 worth of cost. So it could be much lower cost as well. So there are a lot of advantages, and so that's what we envision as a potential solution to the current problems that patients with type 1 diabetes face. So let me talk more about the specific project, having gone through kind of the current problems and the rationale and the solution, potential solution. So we've collaborated with a scientist at Memorial Sloan Kettering Cancer Center by the name of Danwei Huang Fu, who's used some novel genome editing techniques to genetically modify human embryonic stem cells. And what we've done together is knock out class 1 and class 2 HLA. HLA stands for human leukocyte antigens. These are the proteins on our somatic cells or cells throughout our body and our immune cells that stimulate the rejection response. So if we can eliminate them on the surface of the cells, that could potentially render the cells inert to the immune system or wouldn't stimulate the immune system to attack them or recognize them. In addition to those two modifications, Dr. Huang Fu has devised a method to overexpress or produce more of specific proteins that are not normally expressed in pancreatic beta cells or islets. Those two proteins are proteins that are co-stimulatory molecules that are required for really triggering immune responses. So if you block them or lack them, with the protein that would be overexpressed, overproduced, then you could downregulate the immune response. And another one is what's called a checkpoint inhibitor. And these have been used in various situations to stimulate the immune system to reject cancer. That's a pathway that's used to damage cancer cells or eliminate cancer cells with some immunotherapies. So we're taking the flip approach by overexpressing the protein, which can potentially downregulate the immune response. So the expression of two proteins that are not normally there that can downregulate or inhibit the immune response, and then knock out or eliminate two proteins on the surface of the cells that are normally there that would make the cell recognized by the immune system. So we've generated 14 different cell lines with the various combinations of these 4 modifications, and have spent some time over the past year to validate them, meaning making sure they turn on and turn off the proteins that we've designed to have them do. We've also validated them from the point of view we want to test to make sure that if these cells are having these genetic modifications, that it doesn't affect the ability to differentiate into islet-like cells. So we've tested that and have shown that they do not dramatically affect the differentiation ability of the cells to become cells that are producing insulin. And we've also wanted to make sure that when they do become insulin-producing cells, that they don't change the expression of these intended modifications, that they don't, the cells don't backpedal to a cell type that without the genetic modifications, for example. So now we've spent quite a bit of time actually doing all that validation. And now we're ready to test these cells. We're poised to test these cells to see if they can escape immune rejection. So how are we doing that? We're doing that work with a couple of other collaborators. One is assistant professor in our department, Matt Brown. He is working on humanized mice. And that is, we can't just go into humans to test these cells. That's not FDA approved yet and not unethical without doing mouse studies initially. So we want to test this hypothesis in mice. And we're first testing the cells in immunodeficient mice to see whether they are able to generate insulin in the animals and lower the blood glucose and cure diabetes. And we're seeing good signals there with regard to producing insulin and lowering the blood glucose. Now, this is an immune deficient mice which lack an immune system, so they accept human cells without rejection. Now, that's not all of us. We have active immune systems. We have intact immune systems. And so do type 1 diabetics. So we have to test it in a human immune-like environment. And there's 2 ways to doing that. There's a number of ways to doing that, but we're using 2 different methods because we don't know which one will be most effective. Matt Brown has developed 3rd generation and very advanced humanized mouse systems. Most humanized mouse systems use embryonic tissue. He's developed a humanized mouse tissue that does not use embryonic tissue, so ethically more approachable. And it's a very unique system, and we're now testing a new diabetes mouse model in that system in the near future, all of which are unique models that we can offer the diabetes research community in the near future. And we've presented some of that data and have shared some of that data at meetings and published some of that data. So we've always been willing to share all that with collaborators and other scientists in the field. But this is a unique diabetic humanized mouse model that we can test these cells and how they rescue diabetes and how they might be have long life in the animals and be not rejected potentially. So we're on the cusp of testing that system, testing the cells in that system. An easier system than a mouse model, but less, clinically informative, is a in culture model. So we can kind of pseudo model a immune system in a petri dish, in a kind of microphysiological system, if you will, by taking our cells and then adding cells from the immune system of normal individuals. In this case, we're getting cells from spleens of cadaver donors who've donated their spleens for research, and then combining those in a petri dish and using some newer technologies to study the interaction of those cells, with the idea that if we do not modify the cells, the immune cells will attack them and destroy them. That would be expected. But if we modify the cells with these genetic modifications, maybe they will have a longer life in the setting of these attackers. They can defend themselves in the setting of these attack cells. So that's the idea of this study. This is firmly in the preclinical phases. It's not ready for large animals studies yet, or early clinical studies. Now, I think the two companies that are in clinical studies currently are using unmodified cells and using immunosuppression. And that's going to be an important and very important proof of concept of whether these cells can function, at least temporarily, under the cover of immunosuppression. So a small step, but it's very exciting that JDRF is supporting some of these early clinical trials, as you well know, with ViaCyte and Vertex. So I think we believe that the technology that JDRF is supporting is going to have a huge impact in the future. The timeline is not immediate, though, and happy to share with you that information and happy to take some questions.
Great, thank you so much, Dr. John Odorico. It's amazing the work that JDRF researchers and scientists are achieving for those living with the disease. Now let's turn to see if we have a few questions. My colleague, Michael Mayberry, has been fielding some from the Q&A. Michael, can you pose one or two questions to Dr. Odorico?
Sure, thank you. So Dr. Odorico, the first is the dreaded question of a proposed timeline. I think anyone who sat in your chair before doesn't really like to get that question, but it is the one most commonly asked. So I assume you have an answer of some sort.
Sure. Yeah, I would say our timeline for this technology, if it's successful, is probably 5 to 10 years. 20 years ago, I said the timeline is probably 10 years for technology of stem cell therapy. So, what they say about predictions, frequently wrong. But nonetheless, there's significant promise to it. It's not just our lab working on genetic modifications. JDRF is funding other labs working on genetic modifications to modify the cells and help protect them from the immune system. There are other potential benefits from genetic modification through the genome editing approach can target as well. One could make the cells more fit, more stable in human, less susceptible to low oxygen, and better survive the transplant procedure. So there's a lot of potential aspects, but this is, I would view this as version 2.0 or 3.0 compared to the current preclinical studies.
Thank you. A couple more just came in. So the first one is, have you seen any initial data regarding the acceptance of the cells, whether that varies by the age of the recipient? Will an adult or a child be more receptive than another age group, for example?
Right. So the FDA will absolutely mandate the first trials being in adults only. And that's typically for all drugs, all therapies. It's not unique to this, probably, unfortunately. But having said that, I think that it's not clear whether there'll be a whole lot of difference. Adults over time may lose some level of autoimmunity. As we age, our thymus, which makes our T cells, becomes a little bit more atrophic or less robust. So it might be that the barrier to autoimmunity, protection from autoimmunity, protection from rejection, which are two different processes but similar, might be better or easier to overcome in an adult than a child.
Can you connect the dots between the work that you were doing with genetic modification and encapsulation? How do they compare? How are they connected?
Sure. So encapsulation and genetic modification are kind of two approaches to the same problem. And that problem is immune rejection and recurrent autoimmunity, how the immune response might reject allogeneic cells or cells that are foreign to the patient. And so encapsulation is this micro and macro encapsulation. You've heard about this from JDRF videos. It's a teabag approach, it's the macro encapsulation. Little bubbles of alginate or the macro encapsulation. That's the approach that ViaCyte tried and others are trying. It's not, and there's still a lot of work being done, a lot of great work being done. It's still not ready for prime time in my mind. The packing density is a problem, getting enough cells into a small device without them having a core that is susceptible to lack of nutrients and lack of oxygen. That's one of the chief problems. And then fibrosis around that device. The body's tendency is to exclude it and to create a fibrous capsule, which excludes the insulin going out, the glucose going in, nutrients going in, and oxygen going in. So those are the essential problems. There are a lot of smart people working on it. JDRF has made a lot of progress on this. They have a consortium that has brought engineers and biologists together. That group meets twice a year, now virtually, but been a lot of great work in that area. And I'm sure you've heard of it, and I would encourage you to invite some other experts in that area to your annual meeting. I'm happy to talk more about that, but I know time is short.
Thank you, Dr. Rico. And please, we know that there were many questions, and as Dr. Odorico just mentioned, we want to celebrate everything that we can, including this great research. So we will definitely pass those on to Dr. Odorico.
Thanks, Heather. Thanks, Dr. Odorico.
You're welcome. Have a great evening.
Thanks. So now let's celebrate. I think there's, as I said, there's a lot to celebrate. So we're going to do some shout outs and talk a little bit about some of the other work that our chapter did. But as you know, we always have a great walk season with lots of personal touches to families across the state. At the same time, that's true of our ride program. It's our gateway to the organization for many, and our annual coming together and celebrating with our walk and ride families. But last year was tough, not on us so much as it was on families. It was a challenge really to rally troops when families were struggling with how to educate their kids, figuring out the school systems, becoming homeschoolers and remote workers. And so the program took a tough turn. But the good news is we have rallied, and I'm so pleased with our team. I'm excited to say that we are back. So huge shout out to the donors, first of all, who stayed with us and stayed focused on our mission and got creative in the way they raised funds for COVID all around. Maybe we couldn't walk, maybe we couldn't ride, but we could all come together for our cause. So kudos to the staff who really never took their foot off the pedal. And we're excited to see that already this year, we've got a lot of registrations coming in for both programs. And then, of course, a shout out to our second year WALK chair, JP Gallagher, whose leadership really helps us move forward. And talking about not being able to be together in person, we certainly took advantage of Zoom. We did a lot of Zoom things last year, including hosting 2 Type 1 nations, thanks to Melissa Lasky and Laura Dunn. We also worked with our University of Chicago Booth Fellows to craft new programs. And so we launched a program called Research on the Road, where I went out and spoke to 6 groups throughout the state, sharing the latest JDRF news, research, and helping them sort of deal with a tough year. We hosted 2 school nurse training programs, which I'm really proud of, working with not only CPS school nurses, but throughout the state. And so this fall, we're going to launch a caregiver training program thanks to the help of La Rabida Hospital. And we launched a new program for adults. So our Adults with T1 program hosted 5 events last year on nutrition, exercise, mental health. So a big shout out to Chris Nash and to Heather Chamberlain for launching a new program in COVID. So we continued to find ways to open doors and engage the community. And then we had a gala that was presented in a warehouse studio, and a team that tried to think of new ways to engage what was starting to get a little tired, which was virtual events. But thanks to David Carlson and the gala committee, we had a record event. We can't thank our fundraising chair, Glenn Tolman, for all his work leading up to that night. And as I'm sure you've heard, but we're just going to keep saying it over and over again, we raised $9 million, and Cranes recognized us as the #1 gala in Chicago. And it isn't about the events. It's about the work that we do that raises dollars for research. So from that perspective, we had a strong year and more research will be funded. And that's particularly true with some major gifts. As Aaron alluded to and Steve said, imagine this year, $5.5 million in major gifts. That's record setting any way you look at it. And to think about it, not only was it just with individuals, but we had 21 gifts over $100,000 last year. So kudos to all those heroes. And as I said, we couldn't have done it without the support of our volunteer leadership. So on the next slide, you'll see the people we want to do a shout out to. I wish I could do everyone, but really our committee chairs, the people who took these programs on and helped us get through, from walk to gala to real estate games. I can't list them all, but a huge thank you to all of our volunteer leadership. And as I said, we had some amazing champions this year, so much so that the organization has developed a program called One Society. It is now a membership program established for individuals who are committed to supporting T1D research with gifts of $10,000 or greater annually, or a cumulative gift that's of $1 million or more. So this is new for us, and we're excited to recognize these people, to celebrate them, and hopefully this will continue to grow. And speaking of growing, we're always looking to grow our corporate support in the Chicago area. We have 13 major corporate partners who support us with gifts of $25,000 and above. But the laundry list would be too long for all of those companies to support us at all different levels, both in kind as well as financial commitments. So a huge thank you to them. And we got a very special corporate gift this year, which was we were able to work with Kemper Insurance and our international board president, Joe Locker, and arranged for a 3-year lease of gorgeous new office space on Wacker Drive, across, just looking out on the river. This in-kind donation actually saved our chapter $500,000 in real estate expenses. So for us, that's huge. I hope you'll come and see it. It's gorgeous, and we're going to be opening our offices back up in August, so hope that you'll come and visit us there. And as always, we don't just look at what we're doing today, we look to the future. We have 2,800 JDRF supporters who've made the decision, and I think an easy and a smart decision, to support research with a gift from their will or their trust or retirement account. And so we had the Beta Society members who are part of this exclusive group that look to the future and make sure that their gifts are not just now, but everlasting. So we recorded $6 million in estate gifts this year for JDRF, and our chapter raised $257,000 in planned gifts this year. So as you can see from the chart, there are highlighted names. Those are our new members. Welcome to our 8 new members of the Beta Society and to the 67 members in our chapter that participate. So thank you. And then we always close out the year with a wonderful event brought to you by our Young Professionals Group. A second year in a row, they put on a virtual event led by Maddie Schicker, who put on a fun and engaging YLC. We called it the YLC One Last House Party, hoping that it was the last time we had to do it this way, and looks like that's true this year. This group really rallies their friends and their families to support diabetes research. So a huge thanks to Mati, who's been a great leader for this group. He's completing his second year as president of the YLC, so we thank him. And I think he's leaving the organization in good stead. And from our YLC to our youth ambassadors, we have individuals who come together for their passion. They are a huge part of our organization now. They tell the stories. They are the face. They speak at board meetings. They help with fundraising events. They do their own fundraising, and some of them are really good at it. And they put a face to the disease. So their storytelling helps bring in dollars to our mission. And so we wanted to thank all 27 of them for sticking with us again this year. And finally, I want to tell our staff to please take a virtual bow right now for all the hard work that you have done. Remote is not easy. Reinventing plans is not easy. Putting on virtual events is sometimes harder than in-person events, let me tell you. And they do it always with that same drive and commitment to make it the best. They are my heroes of this year. And so are you. All this year, I can't tell you, the team effort that JDRF lives by makes going through bad times bearable. So a huge thanks to Steve Dragich, who's our board president. He leads us with such grace and guidance. And a thank you to every board member, committee chair, member, faithful supporter, and a huge shout out to our new community who've just realized that they are going to face this for the rest of their lives. Welcome. We're a wonderful place to be. Hang in there because great things are coming next year. You heard it here first. So now I'd like to ask Steve Dragich to close our program with a look ahead.
Thank you, Mimi, for your very comprehensive report and just review of our terrific results last year in the face of incredible challenges. And a special thank you to Dr. Orderico for your very informative presentation, mostly understandable. But still some challenges. So I've got to work on the science a little bit, but thanks again. We are inspired every day by stories from the JDRF community members showing ingenuity, commitment, and tenacity, individually and collectively. Therefore, we are more energized than ever to continue this work. We can't take our foot off the gas, and we can't do this without you. It's not about what we have already achieved, but it's about what we have yet to achieve. So before I go, I want to take a moment to thank all of you, our guests. Thank you for all you've done and for all that you will do in this coming fiscal year. Together, we will turn type 1 into type none. So thank you all for attending. Be safe, be well, and I look forward to seeing you in person when possible at our many events this coming year. Thanks again and good evening.